Okay, welcome back, guys. We're about to finish the NumPy part, but we may also do a revision, and in the time we'll have a recording because we missed some of the parts. Okay, then what is left actually now? I may show you some NumPy related to what is this? Let me see my note. Yes, yeah, I was here. Sometimes we may use the seed, NumPy seed, because the seed allow us to generate the same number all the time. Now, let me show you. And now I am interested to generate from 0 to 10. I mean, between 0 and 10 and 21. Then I just run, let me just print integers. Integers. As you can see, I am printing from 5. Yeah, so this. Then at any time, I can get this data because I use the seed. If you change also this with some value, like for instance, 1, you get a different, result, but I have 2 times here. I have to remove this. Yeah, I found this. But with seed 1, I usually get the same random. Because sometimes if your data continuously changes, it's hard to evaluate, right? Sometimes you may want to have your data the same, remain the same. So we can use the seed method. Yep. Then now let's move on to matrix of NumPy. The matrix, you know, matrix most probably. Let me show you matrix. I will just take you to linear algebra. Okay, so it just took me to something else. Usually matrix has such kind of structure, as you can see, rows and columns, and we can add, subtract, multiply, divide matrix, yeah, and we get some values, and that's just matrix calculation. Maybe, so if you took linear algebra or mathematics, you know it. So for instance, here we have A plus B and we get C. If it's just addition, it's straightforward. We just plus this value 1 and 5 to 6, 3 and 2, and it's 5, minus 2 and minus 1, minus 3. Yep, it's 3. And subtraction is also straightforward. Multiplication is a bit different. So let's see multiplication. For instance, as you can see, you have A, B, C, D, E, F. And so as you can see, A times E. So A times E, and then plus B times the G. So this with this, and this with this. You get this value. And then again, A times F and B times H. So we don't have to do it manually like this, but I'm just giving you the insight what matrix was and look like. Then actually this NumPy will take care of that. So first we have to have a matrix, right? Let's create a matrix, for instance. I have this 4 by 4 matrix, and once, let's see, you have to print 4 by 4. Yeah, it looks like this. Well, because it's just in Numpy 1's 4 by 4. And now you can just, if you want to, for instance, change some of the parts, I think it's possible to change some of the parts using as array method. I can show you here some method I have used to change some of the this numpy as array, and then as you can see 4 by 4 matrix, this one, and then go to the second rows 0 1 2, and we are changing it to 2, then this will be 2 2 2. It's similar to what we did before. As you can see 2 2 2, so we can modify some part. Now we have this matrix and this matrix actually. For instance, to create a matrix A, you can just put it something like this. I can say, what's matrix A already? I can just, I have this and just multiply by 2 because it's a scalar multiplication, right? And then if you just, now as you can see, we have, I multiplied by 2, and let's have B actually. B matrix 4 by 4, and just let's have this. And how does 4 looks like? Print B. Oh, as you can see, 4 4 8 4. Yeah, so now we have 2 different matrices, so we can add, subtract, whatsoever we want. Okay, then we may say A plus B, A. So it's not something, actually it's the same, like if you do also just A plus B, you just get the same thing. Because it's just add okay, plus B. Let's see. So in matrix, if we do, for instance, this with this, we should get 2 by 6. As you can see, 6. And if we want this by 6 6 6. And if we go for this part and this part, 12 12. Yes, so it's, then the same goes for minus. We do just minus this. And but for instance, if we want to transpose maybe A times B, how A times B? Let me show you. Numpy mult. No, actually. Matrix numpy dot matrix multiply. I have to just check mat mult. Yes, I think I go for that. Yes, numpy mat mult, and then I can pass A and B, and this the product of this by this. And then if you want the transpose of this again after, actually you can do, let me see from my notes, also a transpose numpy transpose, as you can see, and then no, what did I do? Transpose, and then you just put this value. The transpose is, as you can see, yeah, the flip, we just flip this value. You can also the transpose just by with a capital T, and we should get the same value. Let's compare this, by the way, in if it's equal, everything is true. Yes, yeah, as you can see, everything is true. Then even you can check this num dot all and just put all this value, and if you get everything true, that means this and this were similar. And yeah, I'm just showing you some complicated way of checking, but so what can you learn from this? I think the sky is the limit when it comes to NumPy. Last, I want to do this data, and we apply descriptive statistics for the age of my students. This is the age of my students. So I can say array. I can change it to NumPy array first, NumPy.array, and then I change it to like this. And then num.mean array. As you can see, the average 8 or the mean and standard deviation. And again, standard deviation. By the way, you can also say array.mean like this. It's also possible to get the data out. And you may say the n median and what's the and mode. There's no mode when it comes to NumPy. Okay, instead we can add from SciPy import stat. Yes. From SciPy import. Okay, wait. Import SciPy. Okay. From SciPy, we can say SciPy. That's, I think it's a S. So we can import it like from SciPy import stats. Yeah, it should be something like that. Then we can access the mode. Stats.mode and then array. As you can see, the mode is actually 24. How many times? 4 times. So many of my students, not many of, we can't say, but there are 4 students who are 24. Okay, then NumPy.variance, take a variance like this, and maybe what number has not to be variance. Maybe it's just a var. Yeah, as you can see, it's just a var variance. Even it has percentile, NumPy.percentile, and then you pass just the array, and then which percentile? The 25th percentile, or the 50th percentile, or the 75th percentile most of the time. Of course, you can change this number to different values because it shouldn't be only 25th, 50th, or 75th percentile. Okay. So now, as you can see, it's straightforward. We just use the NumPy methods to calculate or to calculate the descriptive statistics. We don't have to write our own custom functions. This is what we learn, you know. But the first time we've been writing a custom function by ourselves, that was just a means to learn. Okay, after I said this, what I want to do, I would like to revise what we have covered today. So today we have learned about NumPy. So what's NumPy actually? As you may see from this text, it stands for numerical Python. So it's more of related to numbers and the calculations. So most of the time it's used for scientific purpose to do data analysis, modeling, machine learning. How do we import? As you can see, import NumPy and as NP, just to shorten it. And for visualization, we need also this the matplotlib. We can check the version like this. Then creating NumPy arrays. We have a list, as you can see here, and it's good to check. And then everything here is just a list. Then we change the list to NumPy array. So NumPy array, you pass the list. And then, as you can see, the data type here, NumPy, n-dimension array. And then again, list of lists. This is just an ordinary list of lists. And we pass to the NumPy array, and it gave us a two-dimensional array. As you can see, a two-dimensional array, it has three columns and 2 rows. Great. And again here also a list of lists, and then we change it to array, NumPy array, and we checked actually the dimension, and the attribute help us to find or to get the dimension, and it's three-dimensional because, as you can see, it has actually additional 2 square brackets. It's list of lists. Yeah. When we create NumPy array, we can also decide the type of the data. It could be an int, it could be a float, or it could be a Boolean or a complex number. Now, as you can see, it's we are assigning it as a bool. So 0 is a false value. -1 is true or true value. Yes. And then again, 0 is false, none is false, and this is false. And we have seen previously that empty data like a set, list, dictionary, or tuple, if it's empty, is also a false value. That's what we noticed. So what do we learn from here? We saw that it's possible to create a different data type list. Arrays. NumPy attributes. The NumPy attributes like item size. We saw shape, item size, and dimension. And the different, I think it's here in the dimension, shape, size, and data type, and item size to check. For instance, we got here the shape of this value, this list, or this array. As you can see, it has just 4 columns, and the size is actually, size means the total element 4, data types int, and the data size in bytes, it's just 4. A list of lists, again here we have 2 columns and 3 rows, and as you can see, 3 rows and 2 columns, and the size total all elements 6, and the type int, and each item has a size of 4 bytes, and we can change actually the array to list. We change it back. 2-dimensional array to list, yes. And then tuple can be also changed to an NumPy array. Yeah, that's what we are doing. Iteration, yeah, we do iteration the same we do for Python list. For item in list, and then we just print out each item. That's what we are doing here. Okay, then list of lists. It's the same, but as you can see, we get just the list item, then we have to have a nested loop like this to get each item out. Instead, actually, we chose to use this and the enumerate, which give us the location and at the same time the size. Then, as you can see here, I am destructuring it. But actually, this is an example for a list. It would have been much better if it was here. For instance, we can also destructure it here, and we can get this value or this value. Yeah, we have seen already. Then mathematical operation. To do mathematical operation with a list is very difficult, but when it comes to NumPy array, it's just straightforward. We say, for instance, add 10, then you just add 10 to every item. Subtract 10, you just subtract 10 from each item. Multiply, you can multiply every item by 10. You can divide every item by 10. Yes, the same goes for all the mathematical operations. So that's why we say it's so easy to do mathematical operation using NumPy array. Okay, X, NumPy arrange, not range, arrange this starting value and ending value. It's not inclusive. So as you can see, you have X value, then we just squared plus 10, and then we managed to draw such a lovely parabola. So P and the T show, then we don't have to have now, as you can see, we are using also the seaboard. This background made it look great. Yes, indexing. Yeah, we use indexing to access this by 0. And if we come from the other side, -1, right? It's the same for array, NumPy array, yeah? But the difference here, you've been also a bit puzzled. For instance, if I want to extract just the first value, yeah, I may just do again, because this two-dimensional, right? Two-dimensional array. If I'm interested in the first row, just 0. I get the first row. And I think I have to say first row. Yeah, the first row. So we have to really print first row. Yeah, great. And then we have to get also the second row. And let me say second row. Tell me, how do I get the second row? What's the second row, guys? What's the second row? Yeah, just we go 0, 1. Just to check, print second row. Okay, then let's check the third row. Third row. Now you tell me.
2.
Okay, two-dimensional and just 2. Great. Now, I think the most interesting part, if you tell me the first column, then that would be nice. First column. How do I get the first column? The first column is this one. So now I have to use this with a comma and with some colon. So first I have to slice this part, right? This part. So how do I do that? Actually, to slice first, I have to slice from 0 to the end. Okay, then, and then I have to target the first value. Then that means 0.
Okay.
Then print, print first column. Let's see if we have 147. Then I think I will ask you guys then second column that is two-dimensional, and you just tell me, how do we do How do we extract? Again, the second column, we have to go from 0 to whatever, and then, but we focus on the second value. Let's see, print second. Oh yeah. Then now let's try the third dimensional, and you tell me now. 0 to whatsoever, and then 2, and I think this should give us third. Yeah, 369, 369. Great. This is what we've been, and even we've been reversing, if you remember, we can, yeah, but now we've been also doing slicing some part. Guys, now I want you to slice 1, 2, and 4, 5. One, 2, and 4, 5. So first we have to slice this and this, right? Yes. Where was our
0,2?
Yeah, we can do it here. So to tell me
0,2.
0,
2.
Okay, if we say, for me, this gives me 0 means the first row. And you say that 2, then 0, 1, 2. This give me only 3. This give me, this is what I'm expecting from this code is 3.
Okay.
Yes, because 0 will help you to get this value, the first row, and then 2 from this 1, 0, 1, 2, that means 3. So you have to think again. But you can say 0 to 0, 1, 2, you can go up to 2, and then here also you may say 1, 2, 0, 1, 2. Yeah, I think the same, 0, 1, 0 to 2. 1, 2, 4, 5, 1, 2, 4, 5. Yeah. By the way, now we got this value, right? Can we modify this value? For instance, it's just, but let's just take this down because I don't like to just write it everywhere. We've been somewhere around here. And yeah, actually we've been just working here now. How about if I am interested to modify the values? You can just give values like, for instance, I change this value to 20. Yeah, let's see now this two-dimensional. As you can see, I select these guys and then the value has been mutated and modified. Have you seen that? Yes, great. I think now you got the idea how that works, and let's move on to other part. And then we saw how to create zeros. It's so powerful that numpy.zeros, and then you pass the shape. 3 columns and 100. 100 is too much. Let's change this to 5, okay? As you can see, yeah, 3 rows and 5 columns. And the data type int. You can change this float or int or complex, or even a string, and that will be 0 as in a string. Let's see. Yeah, but as you can see, 0 means like in a string empty value. That is okay. Let's see by changing it to complex. Okay, and even you can generate different data types of 0, but still it's 0. Okay, now let's just change to int and move on. Numpy 1 similar to zeros. You can generate 0 values, 3 rows and 10 columns. Yeah, and Numpy full is so special that you can create whatsoever you want. For instance, 3 rows by 5 columns in the value we are looking for. It could be 5, for instance. Then as you can see, 5, 5, 5. And 3 rows and 3 rows and 5 columns. Now maybe I think I can change this value to 4. 3 rows and 5 columns. Numpy I allows you to create a diagonal, such a kind of what vector they call it, unit vector, or what was this, the name of this? Sorry, my voice. And then let me just change this to 10. As you can see, this diagonal is all the time 1. So we call it numpy I, and you can change this in the dimension increase. This, for instance, 10 by 10, it's a square matrix. Numpy empty just create a different shape of numpy array with different data type. Reshape, we learn, for instance, numpy arrange creators from 0 to 11, that's 12 items with in 1 dimension. We can shape it 6 by 2 or 3 by 4 or 4 by 3. Why is that? Because I didn't run some of the codes. You have to run, okay? And then, yeah. So reshape, flatten. If you have a second dimension or a third, you can change it to 1 dimensional. You can change it to flat. Yeah, flat is very powerful. So you can change it. And then we learn concatenation, actually concatenating. For instance, if you concatenate this list in just ordinary list, it 1, 2, 3, 4, 5, 6. But in numpy array, it will be addition 5, 7, 9. So 5, 7, 9. So to concatenate, we have to use numpy, concatenate, and we have to use this as in a tuple, array 1, array 2. If we want to concatenate them in a reverse order, we can change the value, okay? The parameters. And then again, where we see here reshaping, and we can actually concatenate here for horizontally or vertically by changing the axis. Yeah, what does that mean? Now let's change this 1, and it will be columns. Because I didn't run some of the code, so it doesn't work. Yeah, do you see now? The concatenation is actually from horizontal size, but if you do this, it will be more of as in rows. And yeah, Femi asked me to do transpose. Transpose actually is a mirror image or inverse of what we have. So the inverse of this is actually this 1. And then we can do horizontal stack or horizontal is the same as what we've been doing. Where is it? We did somewhere, so it's the same as that horizontal concatenation. Now, random numbers are so powerful to create data, random data. So for instance, this numpy.random, if you just do not pass any value, it just gives you why, the how. Let me try again. It's surprising. It's reason I'm expecting just, oh yeah, because it's not that number. Okay. Yeah, as you can see, if you don't pass any argument, you just get 1 value. But if you just give 2, I will get 2. Then even if you pass 2 by 3, that means actually I'm expecting 2 rows and 3 columns. Yeah, but we should pass this as in this. And you may call it size and like this. Or you don't have to write the signs, okay? It's just something like that. So if you want to create a different shape, you can change this. 20 rows, 30 columns, whatsoever you want. And actually, this gives you floating number. So how about if you are interested to create integers? This gives you something amazing. Let me show you here, guys. So for instance, if you say 10 to 100, actually we are trying to generate a number 10 to 100. Let's see. Yeah, 37. Okay, 47. But maybe we can say size and then we can say 10. Yeah, as you can see, we are looking for from 10 to 100, 10 numbers, and we got it. Yes, maybe we can change the size or the shape here, maybe 2 rows instead of 1 rows, 2 rows. Yeah, it's great. And then we saw this choice. We have vowels in. We want to choose 3 of them from the vowels. Yes. And then we do use this method to generate a random ID for users. And what we did actually, we chose A to Z, both uppercase and lowercase, and also 0 to 9, and then list, the changes to list. And then how many times? Depends on the user. 3 to 6, but by default, we put it 6. Then as you can see, if you don't pass any parameter, it gives you 6. But if you pass parameter, it gives you that size. Great. And then actually we use this, the random.uniform data generator, the minimum -1, maximum 0, and total sample size 1000. You can change this, the minimum, you can change -10, whatsoever you want. Yeah, but -1, this is really small gap, and you can change even the value to 10,000. And let's see now. Yes. And now we have this distribution. Because it's a uniform distribution, the difference is actually very just small. Yeah. Now here we have a uniform distribution data generator. We have the mean, the standard deviation, and the total number of samples or observations or the data points that are 100. Okay, then we did, and then we got this awesome distribution. And what we did later, actually matrix in Numpy. So yeah, I showed you here matrix. We have a matrix summation. For instance, this is a matrix. If you want A plus E, B plus F, and C plus G, D plus H. So it's just straightforward. Subtraction is also straightforward. But when it comes to multiplication, AB and EG, have you seen? A with E, B with G, something like that. But you don't have to think about that anymore because this Numpy is so wonderful. So we create with Numpy 1s or by 4, and then we just modify it a bit just to create a matrix. Then as you can see, we have A looks like this, and B looks like this. And then actually we did the additional operation, and you can do the subtraction operation, but the multiplication looks like Numpy matrix multiplication A and B, and then it gives you this. If you want to do a transpose of this, you can transpose something like this. Yeah. By the way, we can store this AB by saying AB because it's a kind of a product, and then just print. Yeah, so then we don't have to just write this all over again. Instead, we can say AB. Oh, yeah. Great. Then here goes the same. Instead, you may say.
I think maybe you have recorded those ones.
What?
I think you have recorded those ones.
What? Oh, I didn't hear you.
I mean, from that stage where you are now, you start recording from that point.
Okay. Yeah, thanks. Then yeah, so I will wrap it up. Then yes. Then, as you can see, guys, then after what we did is actually is just a descriptive data, statistics using this data, just the mean, the standard deviation, the mean, as you can see, you can do in two ways, either directly from the NumPy or from the object, from the array object. So that's possible. And the median, but there is no mode in NumPy, so I use the SciPy stats.mode and then we pass it. And then the percentile also possible to calculate. Guys, thank you so much for taking this long time to follow and to be here from the beginning to the end. Yes, and then I will just publish this on YouTube, and for people who didn't show up, it will be an asset for them to know about NumPy. And next week we continue matplotlib and seaboard as the data visualization and pandas. Thank you so much.